Okay, so Algebra 2, Lesson 1, Polygons. Polygons are flat, closed, simple figures whose sides are segments. Flat just meaning they're 2D, closed, simple figures whose sides are segments. Okay, so these are all 2D figures, but this one's not simple because those segments cross. This one's not closed, and that's not a segment, so these are not polygons. Below here are some examples of polygons. They're all flat, they're all closed, they're all simple, and all the sides are segments. Then, each segment of a polygon is called a side. Each endpoint of a side is a vertex of the polygon. And the plural of vertex is vertices. You see that up here. For each polygon, the number of sides is always equal to the number of vertices. They're always the same. Okay, below here you have a little chart that has the names of polygons. We name them by the number of sides, and it goes all the way down to 12, dodecagon. Beyond that, we usually just say the number of sides it has and gone, or just how many sides it has. If a polygon has 42 sides, for example, we would call it a polygon with 42 sides, or a 42gon, but I don't usually hear people say stuff like 42gon. Okay, then a little thing on concave and convex. Basically, if it has a dent or a cave in it, it is concave. And for these, there are some points where if you connect them, points inside the polygon, that when you connect them, they cross some of the sides. That can never happen with the convex. There are no 2 points you can pick inside the polygon that when you connect them, they're going to go through a side. These are the kinds we typically talk about in class. Page 2. Regular polygons. Okay, unfortunately I didn't give you much to write here. Equilateral means equal sides. All the sides have the same length. Equiangular, equal angles. All the angles have the same measure. And then the sides here are labeled with a tick mark. They're all congruent. And here the angles are. If it's equilateral and equiangular, then it's regular. All the angles are the same. All the sides are the same. And then here are some examples of regular polygons. A regular triangle means all the angles are 60 degrees because you know they total 180, and if they're all equal, you just divide by 3. And it's equilateral. Equilateral triangles are equiangular triangles. And then some other regular polygons. Okay, now there's a little space here because we have a few things to fill in. First one is going to be consecutive vertices. Okay, consecutive vertices. Consecutive means in a row, so 2 vertices in a row. They are endpoints of the same side. Endpoints of, let's say, one side. They would be consecutive vertices. Let's take this hexagon. Okay, here's a side. That point and that point are endpoints of that side. They are consecutive vertices of the hexagon. You can go from here If you start tracing around the figure, the next vertex you come to, it's a consecutive vertex. Okay, then consecutive sides is another one. Consecutive sides are adjacent sides. It's two sides in a row. If you're tracing around this pentagon, tracing this side and then this side, they would be consecutive sides. Adjacent. If you want to write yourself some other note for that, go ahead. You can add more to the notes. Just please write what I'm writing. Then also we have diagonal. We use these a good bit. A diagonal connects two non-consecutive vertices. Segment that connects to non-consecutive, that looks funny, vertices. Okay, so now down here you see some figures. A triangle has no diagonal. There is no segment we can make between two vertices that isn't a side. So, no diagonals. A quadrilateral has two. There and there. Okay, pentagon, a five-sided figure, has 5 diagonals. This 6-sided hexagon, 9 diagonals. Okay, I think that's all we need to say about them for now. You'll be seeing more of them later. Okay, now triangles have 3 sides and 3 angles. The number of those is always the same if you remember from the chart on the other side on page 1 of this. The sum of the measures of the angles in any triangle is 180 degrees. And now we're on to page 3. We can classify triangles by their angles or by their sides. And when you're doing by angles, if there is one right angle, it's called a right triangle. One obtuse angle in the triangle means it's an obtuse triangle. All 3 angles are acute for an acute triangle. And then we saw this before. If it's equiangular, then all 3 of them are 60 degrees. Okay, classifying by sides. Equilateral, 3 congruent sides. And if you aren't very familiar with that symbol, I'm also going to write the word so you know how to spell the word. Congruent. 3 congruent sides. Isosceles is at least 2 congruent sides. So equilateral is isosceles because it has at least 2 congruent sides. Scalene, 0 congruent sides. All of them are different lengths, and that is indicated by these tick marks. Okay, so on to some examples. Example 1, solve for x. Okay, so they give us 2 of the angles. We need to find the third. We remember that they add up to 180, so we can add these. Whatever x is, plus 130 plus 30 has to equal 180, because that's all 3 angles. This is 160. So x is 20 degrees. Oops, x is 20. I don't need the degrees. The degree symbol is already here. I won't make a big deal about that, but I don't need the degree symbol here. For finding x and y on this one, they only have given us 1 angle, but we also know those 2 sides are congruent. And I don't think we wrote that in words this year in your notes, but whenever you have 2 sides congruent, an isosceles. It's also what we call isogonic. Those two angles are also congruent. Okay, so isosceles triangle is also isogonic, which means at least two congruent angles. And always the angles opposite congruent sides are also congruent. So x is 50. Oh, I did it again. X is 50, and those two add up to 100, so y is going to have to be 80. 50 plus 50 plus y equals 180, so y equals 80. X is 50, y is 80. Alright, then example 3. They've only given us one angle again. I'm not seeing any tick marks. But we know that's 8 units, and that's 8 units. We still have an isosceles triangle, which means the angles opposite these sides are congruent. X equals y. So what we're going to do, just write this so if you look back you'll know how we got this. It's an isosceles triangle, so x equals y. And all three have to add up to 180. So let's do 180 minus that 110 is 70. That 70 needs to be evenly split between those two. So we're going to divide 70 by 2. That's 35. So x equals 35, y equals 35. Okay, x and y are the same like they need to be. And if we add all three angles, we get 180. So that's that. I think we have the other side. Yes, we do. On to part C. Transversals. Get this lined up. Okay, so I just want to demonstrate something first. If I have a line, okay, and then there's another line intersecting it, they make, these different angles. There's an acute angle and an obtuse angle. These two are congruent and these two are congruent because they are vertical angles. Right, so we already know this is congruent to this, and then this acute angle is congruent to that other acute angle. These two are supplementary. These two are supplementary. And since, this obtuse angle plus that equals 180, and this same obtuse angle plus that equals 180, those two have got to be congruent. And then it works the same for those. Now, if I move this line down here, the relationship has not changed. Right? It's just in a different place. So whenever we have parallel lines, you can think of it as here's where the lines cross, and then we just split it down here, and here's where they cross. So that means this angle is the same as this angle. And also, this angle is the same as this angle. Now, right now we're assuming those are parallel. Nothing here tells us they're parallel. So what we're going to do is put a symbol, not at the ends of those, but on them. That's indicating that they're parallel. Okay, those symbols indicate that they are parallel lines. Alright, so, I don't think I have a lot you need right here because it was kind of taken care of right there. If two parallel lines, we have to get some terminology down now. If two parallel lines are cut by a transversal, okay, the transversal is just the other line that's not parallel, the line that crosses. So we should, I guess, write that up here. A transversal is just a line that crosses another line or lines. Okay, so when two parallel lines are crossed by a transversal, it makes a whole bunch of angles, and each corresponding pair of corresponding angles is congruent. Corresponding angles are ones that are in the same relative position. So these two, for instance, they are corresponding angles. They're both above one of those parallel lines and on the right side of the transversal. So corresponding angles are in the same relative position. Okay, alternate interior angles are congruent. Alright, so interior angles are between the parallel lines. I'm just trying to think where to write this. Interior angles are between, they're on the inside of the parallel lines. Alternate means they're on alternating sides of the transversal. Okay, alternate, they're on alternating or opposite sides of the transversal. So here, let's do this angle and this angle. They are on alternating sides of the transversal and they're both between the parallel lines. They are alternate interior angles. Okay, then also, I'm not sure, hopefully this will work for everybody. For alternate exterior, okay, they're on the outside of the parallel lines. But they're still on alternating sides of the transversal. So that would be, could be this one, and then I need to be on the outside of the other parallel line and on the other side of the transversal, so that would be this guy. These two would be examples of alternate exterior. There are others. These two are also alternate exterior. Basically, you get a whole bunch of angles where all the obtuse ones are the same as each other and all the acute ones are congruent. And that's alrighty, almost done. Part D, proportional segments. When two transversals, okay, now we have three parallel lines with two different transversals. There it goes across in there. When two transversals intersect three parallel lines, the parallel lines cut the transversals into line segments whose lengths are proportional. That just means A over B equals C over D. It's over here. Those segments are proportional whenever this situation happens. Okay, that means the ratios are equal. And if we can find a scale factor, then we can find a missing part. If we know three of these, we can find. So for instance, if we are told that, let's say A equals 2, B equals 5, and C equals 8/3, we're going to find D. Okay, so first I'm going to label the picture, I guess, would be easier. So here's 2, 5, 8/3, and then just D. So what we're going to do is find out what you take times 2 to get 8/3, and then we can take that times 5, because they're to the same scale. So what we're going to do is write 2, and then SF for scale factor. And the little arrows because I'm going from the left to the right. Sometimes they end up the other way, and this just helps you keep track. So 2 times the scale factor is going to give me 8/3. So it equals 8/3. Now I just solve for this SF. So I do the opposite of multiplying by 2 on I. We're just going to multiply by a half. That's what I'll do over here. 1/2 times that. 1/2 times this. Cross cancel. Looks like the scale factor is 4/3. Write that neat. Okay. Then we're going to multiply the scale factor times this 5, and that'll equal D. So since that's a fraction, I'm going to write 5/1 times my scale factor equals D. Doesn't cancel, just 20/3, and you may leave it in upper. That's it. I'll see you soon.